Hi, Alexander.
Hello.
Hey, I had a calculus homework question I was wondering if you could help me with.
Okay, sure. What's the question?
It's asking me to find the equation of a line tangent to a curve at a given point.
Okay. Do you have
Um,
the curve and the point?
I do.
Okay. If you would read those off to me, that'd be awesome.
Uh, it's y equals 2x to the third
Okay.
plus 4x squared, and then minus 5.
Okay. Cool, cool. And what was the point?
It's going to the point 1, 1.
Okay. Cool. So if it's okay with you, what I was going to do was I'm actually going to make a similar example to this. It's going to be very similar and show you how to work that one out. And then, if you like, you can walk me through how you would do this one. Does that sound fair?
Yeah, that sounds good.
Okay. So I'm not. It's going to be pretty similar. I'm just going to do y equals 4x to the sixth plus 8x to the fourth. Let's just do minus 5. Let's do minus 5x. Is that fair?
Cool.
Okay. And let's have this go through the point. Let's just do -1. Now,
Okay.
they don't tell you that they have to do this. They just give you the point 1, 1. But if you're to
All right.
put in this first coordinate into this equation, you will be getting the second one. It has to be consistent. So
Okay.
second point for this is actually going to be for me plugging in -1. So I'm just going to mint it
Okay.
right quick. So even power, these will both be positive ones. And this is an odd
Okay.
power, so this will be negative. So I'll have 4 plus 8 plus 5. So that's going to be 12 plus 5 for 17. So I'm just plugging in this value here and getting that coordinate.
Okay.
Okay?
So the point does lie on the original line,
It does lie on the original line, yeah. Even though they don't explicitly tell
the
that,
original curve,
the original,
right, and the tangent. Okay.
yeah, because it's not necessarily a line, right? This is something that's all curvy and wiggly.
Okay.
That makes sense.
Okay. That makes. Yeah.
Cool. Okay, so now the actual process, now that I have like a different example. So now, if you remember this equation for a line, it's usually called point slope form, and it looks like this. You have y minus y0 is equal to m times x minus x0. Does this look familiar at all?
Yeah. In my notes, though, it says x1 and y1. Does that make a difference if it has
It
a
does.
different number?
It doesn't make a difference because all we're doing is labeling these. So yeah, I could even say like x7, y7. Like it would be silly to do that, but all we're doing is labeling that these are constants and they don't change. Whereas these ones that aren't labeled, those do change. Those are variables.
Okay. That
But,
makes sense.
okay. So your x0, y0, or your x1, y1 would be this original point right here. So wherever you're like starting at on the curve. Now the main thing that changes is, do you recall that in this formula, m was the slope? Do you recall that?
Right. I remember that.
Okay.
Yeah, and that I think back then it was like y2 minus y1, that formula. But
hmm
then I have here in my notes is that slope now is derivative, I
Yeah,
think, right? Does that sound right?
that's what I was going to emphasize. So like, yeah, the old way is y2 minus y1 over x2 minus x1. But remember that derivative is the rate of change of a graph at any point, right? So it's like the slope at any point when the slope's changing. That's what derivative is. And so
Okay.
for here, if we want the slope in the calculus context, what we would do is we would get the derivative y prime, but then we would just plug in our xo to get the y value at that point. So evaluated at xo. Does that make sense?
Right. Yeah.
We want to find the slope at this point. So
Okay. Because that's where the line is going to be. That's where we're going to make our line.
that's where the line is going to be. Yeah, if I do like a little graph here, um, so I don't actually know what this looks like, so don't like take this as the graph, but if the graph looked like this, right? And let's say this was -1 right here.
Mm-hmm.
then we want to find the slope at this point. And you can see that the slope might kind of look something like this for a line that we drew tangent to it. You see what I'm saying? And so
Right. Okay.
at this point, we're getting that slope right there.
Okay.
Does that make sense? Now, again, that's not the actual graph. We might have a slope that's way steeper or maybe negative, but that's just a visual of what's going on when you do this.
Okay. That
Okay,
makes sense.
cool. So let's go ahead and calculate this derivative. So I'm going to do y prime. And recall that whenever you've got constants in front of your variables, you just leave them there, basically. They don't affect anything. And what you do with the powers, so for this first one, it would be 4 times. What you do with your exponents here is you bring whatever it is down. So in this case, I'm bringing down a 6. And then I subtract 1 from whatever that exponent is. So if I subtract 1 from that 6, I'd get 5. Does that make sense so far?
Mm-hmm.
Okay, I'm just going to do the same thing to the rest. So I'm going to have 8 times 4, and then this is going to be x to the third, and then minus 5, and I'll write it there. It's going to be times 1. And if I do x to the 1 minus 1, if I subtract 1, I get 0. And anything raised to the 0 power is just 1.
Okay.
Okay, so if I simplify this, 4 times 6 is 24, x to the fifth. 8 times 4 is 32, x cubed. And then I've just got minus 5. And so this is our derivative. Now, as we were just, if I want to get the slope, I just have to plug in my original x value into that.
Okay, so that whole thing is not the slope. You still have to plug in a value. The slope will come out to be a number.
Right. So you could say this is the variable slope, right? Because this changes depending where you're at the curve, right? If I was over here, then my slope would be like this. So
to find a bunch of tangent lines, I could keep using that derivative equation.
yeah, if you had several different points and you wanted to make tangent lines, so like say at -1 and at, this kind of looks like, I don't know, like -0.01 or something. Yeah, you could just keep using this formula to get all the different lines.
Okay.
So if I plug in -1 into this, so I'm going to do y prime of -1, I'm going to have 24 times -1, and it's to the fifth, but since I'm plugging in -1, I'm really thinking of it in terms of 2 an odd power. 2 an odd power. And that's just because in general, a negative raised to an odd power is still negative, and a negative raised to an even power is positive.
Right.
So this is going to be -24, -32, and then minus 5. So if I put all that together, that's going to be 56 minus 5. That's going to be -61. Making sense so far?
Okay.
Okay. So that's our slope at this point. That's going to be the m that we actually use. So we've got
a really steep slope.
That is a really, and it's steep downwards, right? So that's more like something going whoosh. So there's a really steep slope. We've got our x0, y0 right here. And we're just going to plug it into this formula right here.
Okay.
I'm going to go ahead and erase this just to have a little bit of room. Okay. So let's plug it in. So I'm going to have y minus, my y0 is 17, equals -61, because that's my slope. And then careful with your signs here, I'm going to have x minus a -1. So minus a negative would be plus 1. Yep. Now this is point slope form. Do you know whether your professor or the homework you're doing wants it in point slope or mx plus b form?
I'm not sure. I do have my notes here. You said either one. I think you said either one's fine. I don't. Can you show me the other ones?
Yeah. So this one's nice because it's the easiest one to plug into, and then you can just leave everything there. But the other form looks like, I'll just put it right up here. The other form is y equals mx plus b. And so now m is your slope and b is your y-intercept. It's where the graph actually cuts through the y-axis. And so if I distribute, or I'm sorry, through the y-axis. So when x equals 0, it cuts through the y-axis. So if I distribute all this out, I'm going to have y minus 17. Distribute this in, I get negative 61x minus 61. And then I just have to solve for y, so I would add 17 to both sides. So I'd have y equals negative 61x. My brain, that's going to be negative 60 plus 16 would be the same thing as that, so negative 44, I believe. Yeah, assuming I didn't do that wrong. That's the idea of what you would do, is you would distribute this out and then just solve for y. Does that make sense so far? Uh-oh, hello? Still there?
I am still here.
Okay, cool. Thought I lost you for a second. But does that make sense?
Okay.
Up to this point? Like
Yeah, it does. I was saying that and the notes, because I'm taking notes along with this, that I have that one of the answers is y equals negative 61x minus the 44.
Mm-hmm.
And then, or it could be the one you have up above that, y minus 17 equals negative 61 parentheses x plus 1.
So yeah, so it's kind of up to you, whichever one you prefer to use in that case, but they are both describing the same thing.
Okay, I'm going to put them both, and I'll ask my teacher which one he prefers.
Okay, that's fair.
Okay, so I think I get it. Can I work out the other one with you?
Of course.
Okay, so
what to do?
Y equals 2x to the third plus 4x squared minus 5. Okay, so first we need y minus y0 equals mx minus x0, right? Because that's ultimately what we're finding.
Mm-hmm. And make sure you have parentheses. So it wouldn't be mx and then just minus x0. It would be m parentheses x minus x0.
Right.
Okay.
And then now we're putting in the 0.11, which is not too bad. So we're looking at y minus 1 equals m parentheses x minus 1 close parentheses.
Okay.
And then now we have to find the slope, we got to do derivative. So the derivative of this guy is 3 times 2 is 6x to the 2.
Mm-hmm.
Plus 2 times 4 is 8x to the first.
Mm-hmm.
And then what do I do? The minus 5, that doesn't have an x. Is that x to the 0, or what do we do there?
So yeah, so whenever you take the derivative of a constant, it just becomes 0. And you don't have to, you can just memorize that constants go to 0. But something kind of sneaky is that you could say this is x to the 0, right? Anything to the 0 power is 1, right?
Right.
If I bring down that 0, what's anything times 0?
Oh, yeah, that makes sense. Times 0, or it becomes 0.
Cool.
Cool. All right, so that's our derivative. And now to figure out the slope, though, because that's not the slope, that's just, I mean, it is, but at this point.
Right.
So I'm going to plug in 1 for both x's, and then we just get, was that just 6 plus 8?
Yep. That's it.
14.
Yep.
So then when I plug that in 1 second to do that, I get y minus 1 equals 14, and then x minus 1, or parentheses x minus 1.
Yeah.
Close parentheses. And that's one possible answer. And then the other one, let's see, I move over to 14. So I get 14x minus 14. Y minus 1, then we move over the 1. So I'm getting y equals 14x minus 13.
Perfect.
Okay.
Yep.
All right. I think I got the hang of this.
Awesome. Is there anything else I could help you out with?
No, I think that was the last one. I'm just going to double check with my teacher on Monday if, point slope or slope intercept, which one's better.
Which is preferable. All right. That's awesome. I'm glad I was able to help you out there.
All right, cool. Thank you so much.
No problem. Have a good day.